when an alarm goes off, you don't need to waste time searching for related metrics. With Amazon CloudWatch, you can now easily navigate related metrics and logs to troubleshoot issues faster. No more searching, just act.
Well, episode 15, can you believe it? We are on our 15th episode right now. Welcome to your favorite show on YouTube. May I say that? Folks, my name is Kumar Jagannathan. Welcome to the AWS Cloud Operations Show. Today, we're going to focus on observability for GenAI model training and inference. This is for workloads. This is making use of Amazon SageMaker Hyperpod and how you can monitor that environment for when you do model training and inference. To talk all about it, we have some awesome guests with us today, and let me open them up. Folks, please go ahead and introduce yourselves.
I'll kick things off. So hey, everybody, my name is Nicole Murray. I'm a senior solutions architect here at AWS at Amazon Web Services. I've been here for about 6 years, and I focus on working with AI startups and helping them adopt our machine learning portfolio of services. So I'm happy to share some of the information I've learned while working with customers and teach you a little bit about how to observe some of those workloads when running them on AWS, specifically with Hyperpod.
Yeah, and I'm Kevin. I'm a special solutions architect in our cloud operations group, focusing on monitoring and observability, and always happy to be on the Cloud Operations Show. And Amaya, I feel like we need shirts or swag or something. I keep coming on here, but happy to be here today and talk about this topic.
Yes, we should certainly do that. That's a good idea, Kevin. Kevin, you're streaming live from Tampa, and Nicole, you're New York City. Do I remember?
New York City, that's right.
That's perfect. Yeah, in Atlanta, Georgia. Great, fantastic. It's amazing. This is an exciting topic, and GenAI is always an exciting topic. There's so much amazing things happening on that. So many new capabilities opening up, and so many problems innovatively being solved by customers. And it's the core of GenAI is the models, right? The smarter the models, the more capable the models, the more complex issues that you're able to solve. With that comes with you having you choosing the right model, employing it in the best way possible, and also executing it, being or creating an environment in such a way that it's efficient to solve a specific use case. Okay, so not everybody knows what Amazon SageMaker Hyperpod is, including myself. I think I know a little bit, but maybe not everything. So educate us, Nicole. What is Amazon SageMaker Hyperpod?
I am going to give a quick answer to a much longer response. So I'll start off with this. So we have many different ways for you to develop your foundation models, right? Those large language models, or even just regular machine learning algorithms on AWS. I would consider SageMaker Hyperpod one of our mechanisms that kind of mix self-managed, if you will, along with having the same level of resilience, if you will, that Amazon provides you with other services. So what I mean by that is Hyperpod streamlines large-scale AI model development with resilience, automated infrastructure, and all tries to reduce training time and costs by centrally managing those compute resources. Now, it's important for those customers who have large clusters. So the bigger, or rather, if you have thousands of GPUs, there's a really excellent white paper by Facebook that does a great job of explaining this. So I won't go too deep, but we'll just summarize and say it is incredibly difficult to manage infrastructure when you are running resources or applications that are just driving your GPUs to their maximum capacity, right? So you have a high risk of one of those graphic processing units, those GPUs, just failing. So something like Hyperpod has the mechanisms to monitor for those kind of failures and kick off a replacement action, right? If it identifies that any of your GPUs have failed. So for our machine learning customers, typically they leverage it for rapid iteration, prioritizing workload scheduling, zero interruption operations, effectively allowing their teams, which sometimes can be smaller teams with really impressive ML engineers, allow them to focus on the innovation rather than focusing on well, what we call undifferentiated heavy lifting of managing the infrastructure. So at the end of the day, whether it's AI or application development outside of it, we're still using infrastructures to drive our solution.
Yeah, that's awesome. So when it comes to models themselves, like we have, there are different terminologies used: foundation models, large language models, frontier models, right?
Yep.
So frontier models are those that, like, you are the innovator, you're pushing the boundaries, you're going and creating something net new. Correct me if I'm wrong. Again, I could be completely wrong here. Foundational models are those that mostly multimodal, right? Like they can do multiple things, inputs and multiple types of outputs, like text input, image output, text output, could be anything. And large language models are mostly language specific, text specific. They take text input and kind of spit out text outputs. That's my understanding of these things. And a lot of large language models exist today. Like I use a lot of tools to get by, different,
A little help from your AI friend. I get it. Yeah.
Exactly. One of the I love Amazon Q a lot. I leverage it significantly for my application development. Kevin and I, we are in fact working on a pet project, not necessarily a pet project, but a project where we are leveraging Amazon Q developer quite heavily, and it uses Claude Sonnet. That is a large language model, right? And but my question is, why does a customer need to go create their own model while there are so many models already available, so many tools available that already make use of these models to do certain things?
I appreciate that you asked this, because I challenge customers all the time about whether or not they really need to create a brand new model, or could we just leverage something that exists already? I'm going to say an opinion first. I think we're getting towards the point where models are becoming a bit of a commodity, and there's likely a model out there that can do what you need, and you just need to make it a little more specific to the needs of the business, if you will. So I'll start with this. Why would I want to create a new model from scratch? If you have a domain of expertise that none of the available models right now, which could be unlikely,
Are you saying
have
that there
today,
are you saying that there are models that exist that don't have expertise? I feel like all the models that I'm
I'll give you an example for one of my customers, without stating names. I have customers in my patch that also in the medical field or the tech bio field. And sometimes that could be true, right? For instance, let's say you're trying to use a model to identify if there's something interesting. And when I say interesting in this context, I'll explain it after actually. Let's say something interesting is in an X-ray, or the results of an MRI, or the results of some of those outputs that you may get from visiting a medical facility. Some models, in order to get that data, right, to train on all those X-rays and so on and so forth, that tends to be a little more closed, right, than say other types of information that's available on the internet. So I have seen customers need to kind of create their own models that have the ability to investigate these images and find things that the human eye have some difficult times finding. So I can't say it is possible, but for most use cases, it's not necessary, right? You might be able to simply fine tune your model, meaning kind of teach it on a specific set of data. Maybe you might have internal information within your organization that you want to make sure that you train it on. You could use fine tuning and other methods like RAG to do that. And RAG is retrieval augment generation. Much easier way to kind of get new data into the eyes of an ML model. But effectively, my point is there are many different ways to figure out how to take a general model and ensure that either A, it's using data from within your business to prevent hallucinations, or to avoid fine tuning, do a little better prompt engineering. I actually advise folks to start with prompt engineering. Can I write a better prompt or query to ask of my model to get the answer that I want? Then kind of think of, maybe let's fine tune if it turns out you really can't get the type of responses you need because it just doesn't have that domain knowledge. Fair, go ahead and fine tune it. And then finally, I don't have any models that know anything about the domain of expertise that I'm interested in. That's when you might find yourself pre-training for something new. That happens a lot.
What type of tools? So I know we have a lot of fully managed things on AWS to do this type of work. But we also have, semi self-managed. How would you pick between the options, and what do we have for those fine-tuning tasks?
I'll take you through how I kind of talk with customers about this, because that's helped me. It helps me define where in the AWS stack of ML services we're going to focus our attention. I'll start with the easiest one, right? Maybe you have a smaller development team. They're not really ML engineers. You want to add an AI component to your application, and you're looking to leverage an existing foundation model to support that. In that case, maybe we'll go for something a little more managed, right? We have a service like like Amazon Bedrock. Bedrock allows you to get access to leading foundation models. That's Claude. That's actually recently OpenAI's models, the GPT model sets, Mistral AI, so on and so forth. We have over 20 that are supported today. You can simply leverage that to make an API call to Bedrock, calling the specific model of your choice. And also, I think what's pretty neat about that too is, since it's just an API call, you can kind of swap models whenever you need, because sometimes new models are going to keep coming out, especially now that we're in the age of AI. And as long as it's supported on Bedrock, you simply just change the API, change to call the appropriate model that you want, and you're good to go there. For my customers who have a little more expertise and want more control, that's when I start to talk to them about either self-managed or managed routes for building, training, and deploying your own models. You can always run your own models on native EC2s, but there's quite a bit of operational overhead on trying to manage building out a MLOps pipeline in EC2. So for customers who don't want to take that operational overhead, that's when I push them to SageMaker, right? Because at that point, you want full control over how you build your models, the process you use for deploying them, creating CI/CD pipelines to keep hydrating new data. Should you want to, I don't know, create a schedule for how frequently you fine tune your model. These are all really cool use cases and totally applicable, but maybe you're going to want to do that with SageMaker versus trying to roll your own in a native EC2 system.
Yeah.
Go ahead.
And I know we're talking kind of about like getting observability and monitoring those types of workloads. Like obviously anything not working is bad, right? That goes without saying. But like, what are some of the kind of like, are we looking at like when this fails? Is there, huge cost increases, or like, what are some of the impacts when you don't get observability over these things?
I'll give you one example. Imagine you needed to train a model and it takes, 7 days to train it. We'll just say that. The time frame completely varies based on the use case. So please don't use that 7 day as an average. But let's say it did, right? What if the hardware crashes on day 3 or 4 or 5, whatever, or really right before you're almost done, it crashes. It is possible to create your own manual mechanism to try to figure out how to pick up from somewhere you left off, but that's actually quite difficult. SageMaker provides you with features like checkpointing, right? So that at each step within your model's training journey, I'm going to take a snapshot of where you are, or a checkpoint. And if you are ever in the unlikely scenario that your machine drops or the GPU dies, the GPU that you're using to train your model, it'll automatically make sure that when we replace that instance and you're back up and running, you don't want to lose all that time you spent training. Instead, we'll restart from that checkpoint. So I would say that's one of the reasons why you're going to want to make sure you have the right infrastructure to support your training initiatives. Or Inference too.
And you have some of this to show us, right?
That's right. That's right. Awesome. So first, let's do it. Can they see my screen, everyone?
Yeah, we can see.
Yes, we got you.
Cool. So what we're looking at is the Amazon SageMaker AI service. I mentioned specifically we're going to focus a little bit on Hyperpod because Hyperpod has that resilience that I mentioned for your GPU workloads. So what I'm going to do is look on the left navigation pane, scroll down. You'll find your Hyperpod clusters, and you've got your cluster management. I've got 2 environments here, and I want to start off by showing how easy it can be to observe your environment when you're using Hyperpod. Now, first, I got to talk about how hard it is to do all this stuff on your own, right? In order to monitor your environment, right, you're going to want to look for a number of different metrics. You're going to want to monitor for your GPU performance, your CPU, what's called epoch, which is related to your training and your throughput therein. And we'll pause there. Now, the thing is, in order to enable visibility for all that, you typically have to install specific drivers to support each and every one of the features or functionalities that you're monitoring. So with that, it's kind of simple. Amazon identified that maybe we can make it a little easier. Instead of having you have to install all those drivers and identify all the different open source resources that you might want to use to, well, collect those metrics and then publish them to whatever solution you'd like to use to visualize them. They decided, why not just make this super simple? We know everyone's going to need it. All our customers are asking our SAs to support this and figure out how to create custom dashboards for it. Let's just make a one-click option. And that's what we have here. So what I wanted to show is how quickly you'd be able to get Hyperpod observability implemented in your environment. It's an opinionated solution. And what I mean by that is it leverages a lot of the knowledge and know-how that all of the the solution architects and specialists have collected while working with our customers to help them adopt our services. So with that said, let's go ahead and show what we do. Here on the page, you immediately land on the dashboard. You'll notice that I have my cluster orchestrated or deployed within EKS. For customers who are on the academic side, we've also got Slurm supported, and that's likely the solution you may want to use because you have a lot of familiarity with that from your academic studies.
So it's not only EKS, there's also other orchestration environments.
That's right, Slurm as well. The thing is, I do want to be open about this. Right now, the one-click process that we have is developed for EKS, but in due time, it'll also be available for Slurm as well. So as you scroll down, you see all the different add-ons that you can quickly add within the environment, whether that be the training operator for customers who want a little more visibility as well as control to manage those checkpoints and your training workloads. Task governance for customers who want to get really granular with how much resources you allocate to each team within your environment, or let's just click Hyperpod observability.
So, but you already had your Hyperpod cluster created, right?
That's right.
Also from within the console, right? I'm just trying to take people from the level 100 point of view, I guess, right?
That's right. So at this point, I've already deployed my Hyperpod cluster, which you can do via Quick Start Guide very quickly. We released that about, I want to say 2-3 months ago to make it really easy for customers to deploy their clusters. Then what I want to show is what it looks like after you've created the environment and you have all those metrics. So I'm going to go ahead and switch over to my working cluster, the one that I spend most of my time in, because I want to show you exactly what metrics it shows are being collected. You'll notice that we've got metrics being collected for training, which is, when you're training your machine learning model. For inference is when you take the model that you just trained, and now you're leveraging it to serve any of your AI calls, right? So when you do your prompt engineering, you're prompting to something that is typically an inference workflow.
So that's kind of like a traditional chat use case, right? Is inference. So that's what that is?
100%. So every time you log into Perplexity AI, you are performing an inference call, and they have an inference cluster to support you.
Not just that, it's also even if there is an image generator or a video generator, anything that is runtime is inference.
That's right.
What I mean by, it's a fancy way of saying runtime. Yeah. Okay.
Yeah. Think of it this way too. If you're someone who uses Instagram and leverage any of those services to create really awesome videos for you, technically you're making an inference call, right? Because every time you leverage it to make that really awesome video or image, whatever that case is, that's an inference call.
Sounds good.
I'll also highlight some other things: scaling metrics, cluster metric. These are all the things that you're going to want to monitor because they either impact the infrastructure, your training event, or, well, I guess networking is infrastructure too. So I won't call that out separately.
Right. So what exactly happened? You clicked on that button, right? What happened? Can you give us some insights on what actions took place?
I'm going to flip the screen a little bit and we're going to go to EKS. Okay. because I think it's important to show a little bit about how it supports scale. So thanks for that question. So in your environment, what it does is create pods within your EKS cluster to support collecting nodes from your environment. It leverages a couple of open source tools. Let's go find some of them. Well, I'll start with the pods first. Before I go into the open source tools, I'll tell you what it's going to do to scale, and then I'll tell you what solutions are on the back end to actually support getting these metrics. I think it's pretty interesting how it handles scaling here. So I've got 8 nodes in my environment, 8 nodes for my training event that I have running today. Okay. What it can do, what we do, collector, there it is. What we do is for each node within your environment, it has a dedicated collector to collect your open telemetry metrics, or I'll just say metrics for now, to collect those metrics and push them on over to Grafana for visibility and for your view so that you can make some decisions or just view them, right? I think that's super important because as your cluster scales, this will scale as well. And the neat part is that ensures that, I don't know, if you have a really large cluster, you never want the collector nodes to become a bottleneck to, collecting and managing those metrics. So that's the key point that I'd like to highlight.
Nicole, what is the biggest cluster you've ever seen, like in your time with customers? Like, what are people doing with this?
I would give an example. I'm going to use Perplexity because I think that's one of our public ones that we can speak to. So think about every user. I'm going to talk about it's school just started, if it hasn't started already or is starting, right? How many students are now going to go right back to leveraging Perplexity to, or rather leveraging some AI assistant to, I don't want to use the word cheat, but we'll say to aid their learning journey, right? You're going to need a whole lot of instances for that. In my customer patch, I've probably seen about 125, but for our larger scale customers, they can be into the thousands, right? I wouldn't want one collector node or even a smaller subset of that, right? Managing all the collection for all the metrics in my environment. That is a recipe for disaster if it comes to, bottlenecks and throttling your service. Well, bottlenecks, we'll leave it at that. So yeah, it can go to thousands. But in my patch, since I work with startups, they tend to be a little bit on a smaller scale. About 150.
Makes sense.
So just going back to this collector thing, because there's too many collectors, I'm just focused on that right there. So, so you said there is one collector per node.
That's right.
And that is the collector is running as a daemon set. Daemon set. It is, is it what is a collector? It's an open telemetry collector, is it?
That's right. So let's talk about what's under the hood. And this is where I really want to leverage our friend Kevin here, because actually he was a large part of my learning journey as well, as I focus more on the open source collector piece on the ML journey side. So going back to SageMaker, here we go. So we've got open telemetry, and we've got for our metrics and formatting our metrics. We've got Prometheus, and then we for our collector, and we have Grafana to support visualizing those pieces. And that's why I actually would love to kick it off to Kevin and ask. Just based on your experience working with some of the ML customers and so on, what do you think Prometheus really how does Prometheus add value for ML workloads?
Yeah. So Prometheus was created from the ground up for handling high cardinality. And by high cardinality, basically, I mean a set of metrics with a lot of metadata attached to it. So if we were to think of like your situation with a cluster, and you maybe have, 500 nodes, and each node may have a GPU or however many, and each one will produce GPU metrics. So that's a lot of metrics, and you need to be able to filter and aggregate and visualize those and sort them kind of by these metadata labels. So you might want to say memory utilization is the metric, and I want to be able to have node ID or pod ID or container ID attached to that time series value. And that lets you build these rich kind of experiences. And this particular integration uses a managed Prometheus for the storage of those metrics. And for those not new to AWS, we also, of course, have another time series metric store called CloudWatch. which is also able to visualize a lot of these. This particular integration is with Prometheus, and it takes advantage of this open standard and this open source format, and it gives you like an out of console experience that our customers tend to really like, especially when you're talking about giving someone access who you may not want in the AWS console, but you want to kind of give them a Grafana dashboard. They log in with whatever identity provider you use, and they can see these nice metrics and alerts.
So these metrics that you talked about, Kevin, this collector, the OpenTelemetry collector, is essentially scraping Prometheus targets. Is that what is happening?
Yeah, it's using what we call a Prometheus receiver, which reaches out to the metrics which are produced by something called exporters. For example, like there's something called a Prometheus node exporter. This would produce like CPU utilization, other types of system metrics. Those are produced on like an HTTP endpoint. The collector reaches out and scrapes those, and then we push them up to managed Prometheus for storage.
So are these GPU instances natively exporting metrics in Prometheus format? Like, are there any, let's say NVIDIA GPU, right? I mean, just giving an example, right? Are there specific exporters that also get spun off the moment you enable monitoring or observability on the SageMaker Hyperpod cluster?
Yeah, so whenever you have the NVIDIA enabled instances, I believe, Nicole, and you will get those, that's called DCGM.
That's right.
Exported metrics, and then all we have to do is collect them and send them up.
Got it. So DCGM exporter is also enabled on those instances along with the collectors. Got it.
Yes.
Okay.
That's right. So each one, so similar to how we manage the collector piece for the OpenTelemetry metrics, we've also got an exporter specifically dedicated for the NVIDIA piece as well.
Got it. So this is all open source. There is really no secret sauce that we need to be concerned about or anything like that. It's just standard stuff, right? It's just Prometheus exporter, DCGM Prometheus exporter that gets deployed. There's an OpenTelemetry collector who just scrapes those targets and then sends the data in Prometheus format to the managed Prometheus service. Correct?
Yeah. And I think what you highlight is pretty awesome, because I'm going to go back to the fact that my customers are usually startup customers. They've already started playing around with open source tooling. And some of them are pretty new to AWS as well, right? They just got their Series A or B funding, and now they're ready to start building value. I find that it's really awesome if I could tell them, hey, listen, if you're already familiar with Grafana and those toolings, hey, just start building. We'll help you get the infrastructure up and ready so that you can focus on the innovation piece, and then start using tools that you might already be familiar with. I think that's a really great value add.
Awesome. Sounds good. So you also created the Prometheus workspace already? And when did you point that? Like, when did you point the collector to send?
I did none of that. The wonderful part about the one-click piece is I could have not been aware of how to set up the OpenTelemetry piece, or how to set up the Prometheus piece, or how to set up Grafana. I could have had no idea about that. All I had to do was use that one-click method, and it automatically kicks off installs all dependencies and required services in order to enable you to do that. I think maybe the last thing I'll highlight here, especially because of my history working with government customers, it also integrates with single sign-on. Actually, let's take a look. So it integrates with single sign-on. So I'm going to sign in with my IAM Identity Center. That's where we use to manage your access into your AWS account. I've got it integrated in my case.
Sorry, Nicole, sorry to interrupt you there. So you said Prometheus workspace, that was also automatically enabled. And this is a managed
workspace too.
That is also, so this is actually truly like magic. Like I just click a button and like everything. Okay, that's pretty cool, actually. Okay.
We mean it when we say one click. It's not one click plus some other things you may have to do that we're not going to tell you.
Right. It's truly one click. Okay. And also, Kevin, educate me here. Is it possible that I already have a Prometheus workspace, which is where I want the metrics to go to, and I also maybe have my own managed Grafana, or maybe self-hosted Grafana? Can I put those things into the mix?
Yeah, you could. I mean, these are all things running within your EKS cluster. So the same way you could edit a deployment, you can edit the collector to have a different config and send to an existing workspace. You can actually do it right here through this config.
I won't do that, but yes,
Yeah,
right here on this.
So it works even easier. But yeah, in
Right.
general, OpenTelemetry can always send to any target, and this makes it even easier.
Yeah,
It's
that,
nice,
that gives
easy
me
doing
much
menu.
more. Sorry. So yeah, that makes it even more flexible, right? Like on one hand, it just, hey, don't worry about it, I'll do everything for you. And also at the same time, it says that don't worry, no worries. If you already have this stuff, you can also send wherever you want me to send to, in terms of like sending the metrics to and all that. So which is cool, which is really nice.
And you may have 10 Hyperpod clusters, and they can all go to the same workspace, and then you could get centralization of your metrics, which is always very useful.
Nice, awesome. Now let's go see the metrics then.
All
Let's
right,
go see
fun
that.
stuff, right? So the one thing I want to start with was, I think it's incredibly valuable here that what we're going to show is pre-canned, out of the box, already built dashboards, right? Sometimes if you're
Nicole,
not,
if I could just interrupt you real quick, would you be able to zoom in one so we can kind of see? Yeah.
Is that a little better?
That looks great. Yeah.
I get it. Listen, I've got 4 eyes, but that doesn't mean I can see very well. So they're pre-canned dashboards. Effectively, the goal here is to either A, get you to accelerate the point where you can start observing your environment. Some of my customers, their name to game is their name to fame, game to fame. Forget the expression. But some of my customers, what they do, they build things like pre-training algorithms. So maybe you're a large enterprise and you're about to train your own model from scratch. And your business might be more focused on just benchmarking the performance of your model to demonstrate that if you use my pre-training algorithm, it's going to help you pre-train your first model way faster than everyone else. I like to call them training accelerators. Not sure what the rest of the world is calling them yet. In such cases, those customers just want to get their clusters up, get observability working, and immediately start focusing on leveraging their research data and data scientists to build or optimize those models and get some benchmarking available. This is one of the ways that you're able to that same developer may not know exactly all the different components within AWS that he needs to monitor. So this is an excellent way to get you started, right? What we are on right now is the cluster overview page. In this particular case, I've got 10 instances, and I want to take a step back and talk about one thing. At Amazon, we've got a family of EC2 instances that have GPUs installed in them, right? Primarily these NVIDIA GPUs. The particular instance type that I chose, these are G5 8XLs. They have one A10 NVIDIA card within them. And so for 10 instances, that's one card each. Some of our instance types could support a total of 8 cards within one instance. So just keeping in mind that you never know, you could have one instance with 8 cards within them. One of those cards could become faulty, and you need to figure out how to manage the fact that you've not only got 7 usable instances and you're paying for 8. That's where another value where SageMaker comes in. So I'll show you something here. First off, it's showing me that all of my things are healthy. I got 8 GPUs in total across that are in use, at least right now. I've got 10 instances, but only 8 of them are in use. It's showing me all these simple metrics. I won't read them all out to you. Let's go ahead and talk about some of the things that I think are helpful. Within SageMaker, you can create multiple instance groups. You'll notice that my instance type is within it. A lot of my customers may be trying to adhere to sustainability regulations that some of their local governments may be providing them or asking them to be mindful of as they're building out AI solutions. In such cases, sustainability actually becomes really important. So being able to monitor the amount of GPU usage that you have, meaning, am I maximizing my GPU utilization for my workload need? Or have I over provisioned and I've got these super performant instances and I'm not using all those that compute to the full capacity? I think I saw a question earlier about cost controls and how I might be able to use these metrics to support that. I think in the chat, maybe I missed that. Maybe I might be wrong. But effectively, that's one great way to find that out, right? So let's take a look. Maybe you can identify how much GPU memory you're using, as you can see right here. You can see how much total power consumption you're using within the data centers that host your instances. In this case, we're using no more than 1.36 kilowatts. So we're not using a whole lot of power right here. So that's pretty good. We can see the average temperature. I think this is super important. I used to be into GPU mining back in the day when folks were mining Ethereum. We're no longer doing that, but it became incredibly important for me to understand, am I running my things ragged up to the red line, and how quickly is my card going to die if I continue doing that? Things like that you can monitor for as well.
And Nicole, like with that red line, like let's say we just want to be notified, like when we get too high, did this deploy that for us as well, like an alerting system, or
Absolutely.
do we have to set that up ourselves?
You know what? That's a great point. So let's have this be a little more dynamic, and I'll jump on over to some of the alerts right here. So out of the box, actually, I put it here just to show y'all as well. So I created a widget to show right here so we didn't have to move over. But these are some of the out of the box widgets that come with this solution. I'll start with things like critical memory temperature, right? Like this one right here. So you can define what you think critical looks like for you. Is it 48? Is it 76? Do you want to go to 80% of utilization? You can choose. I would go a little before my red line to ensure that I can take some mitigation tasks or put some mitigation tasks in place to ensure that we don't go any further. But it's up to our customers, right, to choose how they want to monitor their environment. I'll also highlight a couple other things here that I think are super important. You see this one right here? FSX Luster Storage Warning. FSX Luster is one of our our highly available storage systems that we can use for HPC or high performance computing workloads, right? A lot of my customers are doing what's called distributed training. So that means the model or that they are training, or the ML algorithm that they're training, is kind of resource hungry and requires more than one GPU, right, in order to train it. So as I have here, I have one GPU per instance. Perhaps maybe I wanted to have one training initiative and I need 10 GPUs in order to do so. That's going to require my compute to speak to one another because I'm using these two separate instances as one in order to support my training initiative. Now, in order to share data between them, that's where FSX comes in.
So there's a lot of I/O happening between.
You get it. You get it. And if you're familiar with FSX, we tie storage to, or rather, in order to get additional throughput or higher throughput, you have to add storage capacity. So if you find your workload, your storage is getting, I don't know, close to 72%, I forget the exact number, you'll start to see a reduction in throughput while your training workloads are running. In such cases, you're probably going to want to monitor to ensure you know when you're utilizing a certain amount of storage that's going to impact your throughput. That's what this allows you to do here, to monitor for that specific point, 72%, so that you can take a mitigation step. I'm on the fence about ever kicking off actions on its own, but hey, I get it. The world's changing. You can choose whether you just want to send yourself an SNS notification, which is our simple notification service, or go ahead and kick off an action on your own to go ahead and scale up that storage for your needs.
Yeah, and I think another great thing is that since this is using managed Prometheus, it actually also supports PagerDuty for those alerts.
That's right.
That was just released even, which is a nice, pre-built integration while we're talking about integrations. And, if you're using that to manage your incidents, it's a really great option. And that would just work with this as well.
And all these alerts, they were created, they were Prometheus alerts, or are they alerts created in Grafana?
So these are alerts that are sourced from Prometheus, but the rules are created within Grafana.
Got it. Okay.
It's in Prometheus Alert Manager, to be exact. We're just looking at them in Grafana. You can see the top right data source is Prometheus, so that gives us all that kind of power of the Alert Manager ecosystem.
I see that now. Thank you. So Nicole, this I have one basic question. Who created the dashboard? Did you create it, or was that also automated?
I can happily say today I did not have to create any of these things on my own. The only thing I could say I added maybe is making things a little larger to make it easier to see. But this is all straight out of the box. You don't have to come up with the queries to determine how to get this data, because that could be a challenge as well, right? You don't have to come up with the rules to create these alerts, because that's already going to be provided as well. This is all out of the box features that you get just from deploying that one-click install.
Got it. So the whole dashboards and the Prometheus alerts, all of them, everything is configured out of the box. And obviously, if I'm interested in something else, I can also go create my own, because metrics are there and I can do it however I want. So we talked about model training and model inference, right? So the training part is where you're building the model, and then the inference part is just runtime. You're making use of the model end users are using. Are there different dashboards to look at from different in these different scenarios? And there's maybe partly what I'm asking is, are there different kinds of metrics that I need to be worried about depending on like what the use case is between inference versus training?
Yes. So first, I'll say yes. Second, I currently switched over to one of the 5 available dashboards that are in the system. There's one dedicated for inference. So what you're looking at now is the list of active deployments I have for my inference workloads and where I'm pulling some of the container images from, the number of requests that I'm getting to my deployment. So something's making an API call to my solution. So folks are using it, which is great, right? If I had some issues, if there are any errors, you'd be able to identify them here. They'll let you know about your successful and more performance. I'll summarize and say a lot of performance metrics are available right here for you to make a decision about how you want to continue to manage or maybe even optimize your server. I'm going to call out one particular metric that everyone cares about, right? No one wants to talk with or rather leverage an AI service. I'm going to use a chatbot for the easy example, because that feels really, you want it to feel like a conversation that's happening in real time. No one wants to sit there and see a loading window. Oh, excuse me, thinking window now. I don't know if you've noticed it, but the internet is starting to change on us. They're not saying loading anymore. They're saying thinking. Everyone's becoming an agentic company now. But moving on. Latency is going to be what you're going to want to focus on, right? If you, I think that's a number one metric that you're going to want to make sure that you can reduce to the lowest capability of your application in order to ensure that you can get the fastest communication between your clients or users of your application.
Got it. So, yeah, good. Sorry.
I'll hush because I could go on. So I'm going to wait because I want to show you a metric that I think is going to be super important for you who are trying to figure out what kind of hardware should I use to even support my training initiative. Because I think that's the conversation I have a lot with customers is that piece.
Yeah, well, yeah. So one thing is like, one way in some fashion, wow, I get all this stuff done. Amazing. All these visuals, beautiful looking dashboards, all that great. Yep. But then like, so what? What should I actually be worried about? Like what actually matters to me? There could be so many things. I'm maybe a model developer. What should I be worried about? Versus I'm just the guy who operates this EKS cluster, let's say, right? What should I be worried about? And maybe I'm an end user. Or maybe I'm an application developer who makes use of this. Like maybe I created some agents that's making call to these models that are hosted on here, and I just need to be worried about performance. Like okay, the speed, my worry is latency. What should I be worried about? So I'm particularly interested in like, what exactly is for me there.
I'm going to focus on this from the perspective. Well, first I want to say this. I had a customer who I asked, "What do you want to see?" Sure, we'll create a dashboard for you, but what do you want to see? And bless his heart, they didn't know. So everything. when you're not sure, they say everything, right? So we do try our best to pack as much information as we can because we don't know what information you think is going to be helpful for your workload. But what I can at least say is, based on the questions that I ask customers to determine what instance type to select for their training or inference initiative, I'm going to choose the metrics that I think are important there. Okay. So I'm going to start with GPU memory used. I often have to ask my customers, is your model memory intensive or GPU intensive? I actually, in that case, when I said memory, meant like compute memory, native RAM. But also there's memory on your GPU as well. So that's the third question, right? Is it GPU memory intensive? You'll find that a lot of the video models are, right? The ones that help you generate video content and so on quickly, they will consume a lot of GPU memory. Sometimes developers don't know. They're just developing to make sure the solution works. They're not really monitoring this stuff, but their DevOps folks are. So memory utilization is a big one, meaning GPU memory as well as regular memory utilization, because that helps me understand if I need to select an EC2 instance type that has a lot of memory native on the machine itself, as well as a lot of GPU memory on the actual GPU itself. So I wanted to highlight that. So if you don't see, you can kind of tell how much memory you're going to need on that video card looking here, based on your workload. I already spoke about the inference piece. So latency for inference, I mean, as you can imagine, that's about the user experience. So is that what we want to try and optimize for? Let's go ahead and stick to the latency like I showed you on the other screen. I've already mentioned GPU utilization, but I want to highlight it just in this section where I'm talking about what are some key metrics that you want to use. Effectively, that's the cost optimization piece, right? A lot of customers tend to reach out looking for the latest and greatest hardware, which makes perfect sense. I would want to test my workload out on that as well. But there's no point in paying additional monies for high compute if your application isn't going to consume it. So take a look at your GPU utilization. If you decide to use an H100 or a B200 or the GB200, whichever NVIDIA card you think is great for your workload, if you're not utilizing a good portion of that, maybe we can take it down to a smaller instance type and also reduce your costs, right? So you can focus on spending monies where it matters in your business.
And I think one of the nice things, since this is in Grafana, like you can say, okay, operations person, you can see these GPU dashboard, and we can have a separate permission set that says developer, you can see the inference dashboard, and then we can hide everything else. Because we want the users to see what matters to them, like you were saying, Amaya. And Grafana is going to come with these types of permission sets out of the box, where you can say, okay, you are a viewer of the inference dashboard, and that's the only one you can see. Because you're just developing, your chat application, and you don't care about GPU temperature. But then, like Nicole was saying, if you're the model developer, you want to see all of that. So I think Grafana gives us a ton of flexibility there to, show people just what's important to them and surface the important information.
This is the one time no data feels good, right? When you see GPU errors, but I'll pause there.
That's a good one. That it's green. It's usually, I mean, if it's no data, you would think that it should be red. No,
not today. This is the one time I want it to look like this. But yeah, +1 to everything you just said, Kevin. And I just have to close out with one last key metric. I won't say it's the only one, but a key metric that you want to monitor for. It's storage. There is nothing worse than finding out that the reason why things aren't working is not because you didn't write your code correctly. It's not because you didn't set up the infrastructure correctly. It's because at some point you hit capacity on storage. There are metrics in here as well to help you monitor either native storage on the local machine, if that's what you're using, or on that shared volume, right? That FSX as well. Those are the things you probably want to be mindful of when you're training or managing an inference cluster.
Sounds good. Sounds good. Are there any other specific things that you want to show on this dashboard?
No, because honestly, there's a lot of data to look at. Some of it's really good. I think the last thing that I want to say to help folks who are still thinking about how do I build, maybe you fall into the category of a distributed trainer, meaning you need to have an environment that supports the ability to run your distributed training workload. I just want to highlight one piece here that's super important, and I don't know if everyone's aware of it. At AWS, we have something called EFA, these elastic fabric adapters. These are specifically designed and implemented on our accelerated compute instances, right? The ones with those high performance GPU cards. It enables you it's like a network interface from AWS, and it's designed for low latency and high bandwidth inter-instance communication. Specifically, one feature that it has is called remote direct memory access. It's a technology that allows EC2 instances on AWS to transfer data directly from memory of one instance to another instance without involving the operating system or CPU. Effectively, our engineers on the networking side, they're incredibly brilliant. They identify, hey man, networking in the cloud can be pretty tough. And customers think latency is the most important thing to them, or low latency, right? It's the most important things to them. How do we create a communication channel to support our high performance computing workloads or customers, right? Or the AI/ML customers. EFA is your path to that, right? So if your workload is a distributed training workload, you can ensure that it's taking advantage of this EFA or this elastic fabric adapter to ensure you're getting communication between your nodes at the fastest possible rate. If you see nothing in here, specifically on the RDMA piece, and you're expecting to get, really fast communication between your nodes, that just means we got to make sure that your custom training logic is actually taking advantage of EFA. So
that's more important that's more critical in training models versus inference. Inference is probably happening within a model.
Right.
Like
You're absolutely
not across Yeah. Okay. Got it. Okay.
And Nicole, how do you take advantage of the EFA? Is it custom code? Is it like simplistic? Is it like how do you do it?
So that's where things get interesting. From an ML engineering piece, you make sure that your Docker files and your training scripts have the appropriate options enabled for EFA to be enabled. So it's not super difficult. We've got great documentation to support that, but it's something that would go within because all of these are really containers, right? Something that would go within your Docker container file to let it know that you're leveraging, you want it to leverage EFA as your mechanism for communication between these instances.
Okay, and so the end result, once we enable and turn that on, is ideally we have faster training or just a higher chance of success, and then
low latency.
Low latency.
Low latency when you have many GPUs that are part of your training environment or training needs, and they're all hosted on different EC2 instances. So for example, maybe I didn't have a workload with it today, but I've got 8 G5s, each with 1 GPU. But maybe one of my training workloads needs at least 2 GPUs to train. That means I got to couple those 2 EC2 instances together in order to make sure I get those 2 GPUs utilized as part of my training initiative. That's when you're probably going to want to think about using EFA. Else, today I just kind of put a stress test, if you will. So they're not communicating with one another. I just wanted to make sure that we were showing some metrics for y'all today.
Right. And also when you're building like really generic large language models, like really big ones or popular ones out there, that's running on like thousands and thousands of GPUs. It's not just one that we're talking about. So this becomes super critical because training happens at such a distributed scale and data has to be shared across these nodes at such a high fast pace or high speed, and because the aggregation keeps happening over and over, right?
That's right.
Got it. Okay, sounds good. Okay, this is beautiful interface, and the whole thing is amazing. But I also remember that on CloudWatch, we're switching gears now. I remember that we also have GPU monitoring. How does that is directly on EKS, obviously not through Hyperpod and SageMaker Hyperpod.
That's right.
How is that related to this? Like, I just want to make sure that there's a mind map for the audience that is.
That's fair, because you could be a customer that's super familiar with AWS already, right? You already know how to use our services and you're really interested in leveraging some of the things that you're familiar with, and that's totally fine as well. Like I mentioned, our SageMaker Hyperpod is being orchestrated through EKS today. So right up here, I'm going to go ahead and hit View in EKS. All right. I'll go to Monitor My Cluster. I'll go to my control plane monitoring. And you can get metrics right here from, everything from your port for failed HTTP requests, scheduler attempts, meaning I scheduled a job to run, but they failed, so on, so forth. You get that right here. You also get additional visibility. So let one moment, please, while I pull into that. And let's go to container insights, because I think that's what you're going to want to look for. So
That's in
one moment.
CloudWatch console. Like I have to go to the CloudWatch console for that, isn't it?
I do. One moment, please. I admit I spend way more time in Grafana, but that's just based on the workload that I've been using lately. All right, so I've navigated to CloudWatch. On the left navigation pane, I'm going to go ahead and search for container insights. Cool. This is just high level what you can see, and you can see that it is monitoring some GPU memory just off the bat. As I scroll down, you see some other information and metrics as well. Excuse me, my dog is now chewing on my VR headset controller. Excuse me, girly. Sorry about that. Got a puppy. What you gonna do? So view performance dashboard. I'll click on over to that, and we'll scroll down once that loads up. So on the view performance dashboard, if I scroll down, it does give me some information about some of the things I noticed or I mentioned earlier, right? Your GPU utilization, your EFA availability, like does that node support EFA or not? Tensor core utilities, which is more specific to GenAI frameworks and monitoring that, as well as your GPU capacity and so on and so forth. So we do have some mechanisms donated to give you some visibility therein, without needing to leverage those open source toolings for that.
Fantastic. So these are like you enabled container insights, GPU monitoring directly on the EKS cluster, and then it gives all that information.
That's right. And I think what you were looking for is on the pod side. So my apologies. I will navigate to pod so that you can see for each, I should say this. Each time you run a workload within when you run that training workload, it creates a pod, which is an instantiation of your training event. So you can actually get as granular as a per pod as well if you're interested, depending on how many instances or how many jobs you try to deploy or you want to deploy for your training initiative.
Yeah, that is awesome. This also gives a lot of details, like it seems like, and just like what we saw in Grafana, this also is automatic. If I remember correctly, this also uses OpenTelemetry, Prometheus, everything similar mechanism pipeline. I think the other it just uses the CloudWatch agent, which is able to collect the Prometheus metrics. That's the only difference, I believe. Otherwise, nothing significantly different in terms of data-wise. It's just the same Prometheus metrics that are being sent to CloudWatch. And this dashboard is also automatic, right? You don't have to create anything. This is available out of the box. Great. This is fantastic. And I can take actions right here. If I'm a CloudWatch customer, I can probably even maybe I have, and in the EKS cluster, I have another EKS cluster where I have my applications running. Maybe I have my own agents running there using Strands SDK. Then that is the one that is calling the models that are on this cluster, and all of that is available within this one console. I can monitor my agent performance, all that stuff, and then I can see the model's latency, and maybe that is being consumed by like a website that is also there in my EKS cluster. All of that is in one place. This is amazing. So
you could even kick off an agentic investigation once something goes wrong with the other agent. The agent investigate the agent, and it's all there for
That's
you.
right. That's right.
I'm glad that you mentioned or kicked us over to CloudWatch. I actually had a customer who had an EKS mega cluster, which I haven't really seen a lot of. And they did not know they could come here and get some information about why they were running out of IP address spaces, right? They had no idea that CloudWatch was one of the places they could go just to get this level of visibility. And remember the first screen I showed you, right? Where it showed your HTTP errors. Turns out one of their services in their internal network was down. And that's why they kept spinning up new instances. And they didn't realize where that was the reason why their cost was spinning out of control. So definitely, everyone, I recommend take a look at CloudWatch as your first stop, and then consider whether or not you need to move to the open source tooling to get additional value.
All right, this is fantastic. We're up against time. Nicole, this was fantastic. We got to see a lot, and looks like, we can keep on going, and there's for a few more hours, I guess. But we have to end here. Thank you so much for coming on to this episode today. This was fantastic. I learned a lot. And Kevin, thank you too. I learned a lot from you both today. It's fantastic. So if people want to find you, where the LinkedIn, is that the best place?
LinkedIn, look for AWS Nicole Murray. I'll be the one with dreadlocks. Can't miss me.
Thank you. All right, folks. See you all in the next one. Bye-bye.
Take care, everybody. Bye.
All right, thank you.